R has a package called boot that will bootstrap for you, but to perform basic bootstrapping, you only need a for loop. Here's the sample of dog weights from the lecture. I'm going to call this orig samp for original sample. The sample size is 11, the median is 41. This is the sample median. Recall the sample command. I'm telling it to take a sample of size 11 from orig samp with replacement. If I run this, it will give me a resample. I'll run it a few times and you can see what it's doing. Instead of specifying size 11, I can use length orig samp, which is 11. And that's to generalize the code so I can use different sample sizes and not have to change much. This is doing the same thing. That's resampling. I want to take a bunch of these resamples, find the sample median for each, and then build a bootstrap distribution from them. All I need for that is a for loop. First, I set a seed so I can replicate everything. I'll make a placeholder called bootmed. I want to store my medians in this. For now, it's 10,000 zeros. This for loop is going to resample orig samp and take the median. It will store the median in the ith position of bootmed. I run this, and now bootmed is a distribution of sample medians. This bootstrap distribution is an estimate of the sampling distribution of the sample median. The histogram shows the distribution, and apart from the gaps, it looks pretty normal. We could use the normal approximation for the confidence interval here. It's centered at the sample median, which was 41. .96 is Q norm 0.97501. It's the critical value for a 95% interval from a standard normal distribution. The standard error is the standard deviation of the medians. The center of the interval is the sample median. That's median orig samp. And this interval is a little bit different from what it was in the lecture, but that's because of the random sampling. Here's how you get a confidence interval using the percentile method. When the distribution has a normal shape, the two methods should give similar results. Not too far off, but the percentile method can be used to find the confidence interval for any unimodal distribution. The normal approximation only works when the distribution has a normal shape. And this is more like a 98.4% interval because of the nature of the data. A lot of these values are the same number, so we're not able to cut out exactly 5% of the data. We can use the bootstrap to perform hypothesis tests as well. My null hypothesis is that the population median is 52 pounds, and my alternative is that it's less than 52 pounds. The sample median was 41. How unlikely is a sample median of 41 if the true median is 52? In order to get a p-value, I need the null hypothesis to be true. The distribution is boot med, and its median is 41. In R, just putting boot med plus 11 will add 11 to every element of boot med. So it shifts everything up by 11. The median of boot med plus 11 is 52. So now we have a bootstrap distribution where the null hypothesis is true. The probability of drawing a sample median less than or equal to 41 from this distribution is given in the code here, and that is 0.0078. The p-value is 0.0078. We reject the null hypothesis at the 0.05 level and conclude that the population median is less than 52. R has a bootstrap package called boot, but it's a little difficult to use because you have to make this indexed function to compute the statistic. The reason it's so complicated is that the bootstrap can be used for any statistic, not just the mean or median. You can compute any number from the sample and make a bootstrap distribution from it. Here's the documentation, and you can see in this first example, they're looking at the ratio of two means. You can come up with all sorts of complicated statistics and construct bootstrap distributions of them. But if I use the boot package, I get something similar to what I had before. This boot CI will give 5 types of confidence interval. You see, here's the normal approximation. Here's the percentile method. I'm not sure how these others are calculated. I'd have to look them up. But that's bootstrapping.